second grade. Today we're going to continue to review our force and motion unit. So last week we talked about that forces cause a change of motion and that a force can be a push or a pull. This week we're going to be looking further into different types of forces because we know that the motion they cause is a push or pull, but our forces can actually be separated into two different categories. The two forces are contact and non-contact forces. Contact force is a force applied right there. Normally it's done by humans or robots, maybe in a factory. For example, if you were to kick a soccer ball, you are pushing the ball, which is your motion, away from you, but you yourself are bringing in that force. Just like if you were to pull a wagon, you are exerting the force. Where on the other side, a non-contact force is a force applied from a distance. These forces are forces that occur naturally. Just like the wind, when it blows the trees forward, nobody is pushing on the trees. It's happening naturally. As well as last week, we talked about magnetic force a little bit. And the magnets, no one is holding them together. The magnetic force naturally holds the magnets together. And lastly, this week, we're going to look deeper into gravity and looking at the picture of the apples in the tree. Nobody is shaking and pulling the apple down. It's falling naturally to the ground. It still has motion, and there's still a force that's causing it to fall, but no person or robot is pulling it down and pushing it down to the ground. It's falling naturally. So from the last slide, we now know that magnetism is a non-contact force. It occurs naturally. Magnetism is when one material repels or attracts towards another material. Metals with iron, like paper clips, are magnetic, meaning that they will be attracted to another magnet. Magnets have two poles. Like poles repel and opposite poles attract. So looking at the picture on the slide, you'll notice that there's a blue part of the magnet and a red part of the magnet. The blue part says S and the red part says N. Those stand for the north and south poles. If you look, the two magnets are connected where their opposites are, because attract means to come together, while repel means to go apart. We're going to be diving into more magnetic activities next week. The non-contact force we're going to focus on this week is gravity. Gravity is a force that naturally pulls objects together. Think about the saying, what goes up must come down. If you were to jump up right now, you might go up for a little bit, but you're going to be brought back down to the ground. Just like if you were to pick up a pencil and drop it, it's not going to hover in the air or fly up. It's going to fall right back down onto the table. That is that invisible force of gravity that is pulling us back down towards the earth. It is a non-contact force that pushes us down. Gravity pulls everything towards the center of the earth. If you look here, this is a quick experiment you can do at home, or you can just check out the pictures to prove that. Here is a wooden dowel, and it's holding 3 paper clips. If you notice, each paper clip right now is currently pointing down towards the earth. Even if the person tilts the wooden dowel, the paper clips don't change the position they're pointing. They're still pointing down, proving that gravity is always pulling us down. So here's the challenge. We know that gravity is pulling us down to Earth. So can you create a car that's powered by gravity? If you were to drop this car down a ramp without having to push it, would it roll its way down based off just gravity? So here are some suggested materials you might want to use for your car. However, if you have an idea that maybe aluminum foil or plastic wrap might help your car, feel free to use it. You're not limited to this list. Some of the suggested materials are cardboard, straws, assorted scrap paper, scissors, tape, or glue. But again, use what you have and be creative. You also want to make sure that you create a ramp so that the car is only powered by gravity. You should not be pushing the car when you let go of it. Gravity should push the car down the ramp on its own. You're going to see the next slide that I was able to create a ramp using a box and a cookbook. But let's say you have a flat piece of wood out in your garage, that would be great to use, or anything else that can make an incline. Now we're going to be checking out our attempts. So I did 3 different attempts of my project because in the scientific process, one of the biggest things engineers always do is they always reflect on what they've built, and they've changed things based on their reflections. Nothing ever designed was perfect after the first try. So I tried multiple times to see if I could perfect my design. All right, this is my attempt number 1. So I wanted to show you my first attempt. So first I want to show you how I built my ramp because doing these science projects every week is really all about using what we have. So I actually had a storage bin that I turned upside down, and I had an old cookbook that I'm using as my ramp. Now this is my first attempt in building. I took 2 toilet paper rolls, some cardstock, which is a thicker paper, and some twine, and I kind of tied it up, and I cut it in a way that kind of made me think about maybe how a car is shaped. And when I drop it, remember the goal is that when I let go, I don't push it, I don't do anything, gravity is going to bring it down. And so when I drop it, it does in fact move down, but I want to try a second attempt because I realize I've tied my toilet paper rolls, and I want to see that if I can get them to roll like wheels, if I can get my car to travel down to the end of the counter. So I wanted to take this first attempt video to show you that it's okay to always go back as scientists and engineers and try and change your design a little bit. So I'll be back quickly with attempt number 2. All right, this is my second attempt, and you're going to see that it doesn't go quite to plan, but that's okay because part of the design process is figuring out what doesn't work so it can lead me closer to maybe what will work. All right, I'm back with attempt number 2. So I changed a few things. The first thing I did is I cut my toilet paper rolls. I cut them both in half so that they'll have kind of a chance, hopefully, to roll a little bit more. And then I also changed the design of my car a little bit. I used some tape, and I kind of taped it in so it's more of a tighter shape. And I'm kind of hoping that that might help it travel down and smoothly. So I'm going to set up my ramp again. Again, it's not perfect. I'd love to have, if you had like a big flat piece of wood, maybe out in your garage would be really good to use. But using what we have, I'm going to try again. Attempt number 2, I want to get it to roll farther down my counter. Let's see if I can do it. So that's okay, it happens. I may have made my design worse, but I am going to go back to the drawing boards. I'm going to try one more time. Because good scientists, using my scientific process, I am evaluating, I'm reflecting, I'm going to come back with one more design. All right, this is my third attempt and my final attempt. 3, and I decided to take what I liked about both of my first 2 attempts and kind of combine them. So I actually retaped my wheels or toilet paper rolls back together because I realized it was a mistake separating them, and they did a lot better when they were working together. But I kept the new tighter aerodynamic shape that I gave the car in the first hand. So this is my third attempt. I'm going to see how far it travels. Just going to let it go off the ramp. And as you see, it definitely went way smoother down the ramp than the second attempt. And then my only mistake is I forgot to measure my first attempt and see where it landed. Looking here right now, I feel like it went farther, but I would really recommend at home if you're doing multiple attempts, maybe take a piece of Scotch tape and just measure here, and you can write on the tape like third attempt. So you can kind of keep measuring and keep pushing yourself towards a goal. I want to challenge you guys to do this activity, and I would love for you to post your cars that you made on Flipgrid just like I did. I'd love for you to explain your design and your thought process, why you did something. If you So now I want you to try it out. Please try multiple attempts and think about what you can do to make your car better. Engineers don't just pull out their first design and put it on the market. They keep going back and reflecting and evaluating and changing until they find the best product. Like I said in the last slide, remember to measure each of your attempts to track your progress, or don't, but I think it might add more. And the last thing is you want to make sure that you challenge your family to get involved. It would be super fun to think about who can make the coolest looking car or which car goes the farthest. Lastly, share your car on Flipgrid. I would love to see your creations. The Flipgrid code is linked in the choice board.